Hello, my wonderful sixth graders. We are now into checkpoint 3 of expressions and equations. It's called solve equations, and we'll be doing that by looking at tape diagrams. So here are two tape diagrams. One represents 2 plus 5 plus 7 equals 7. The other represents 5 times 2 equals 10. Which is which? You're going to label the length of each diagram to identify it. And just as a reminder, this is Direct Teaching 1. So we're going to click. A lot of this checkpoints work. You're going to need to be able to use the drawings in Google Classroom. So we hit Edit. And we can see that we have 2, 2, 2, 2, 2, and 2 and a 5. So this one on the right is 2 plus 5. So the length altogether is 7. And this one is 2, 4, 6, 8, 10. So we click here and put in the 10. Then you save and close. So each time you have to use a drawing, that's how you'll edit it. So here, I want you to make a drawing that represents 4 plus 3 equals 7. So this equals 7 is our final sum. It's going to be represented by the length. Okay. So here we have 4 and 3. We want to drag those down inside it. So I just pressed my down button. And our total here is 7. And then this one here, we can see that it's 4 times 3 equals 12. So we're going to need 4 copies of the number 3. So I clicked inside where I saw the red, and I'm going to click away. I'm going to Control C, Control V. So there's my first 3. I'm going to have my line line up with that. And then I'm going to take this 3, put it there. Click on the line, Control C, Control V. You have to hold them both at the same time, the control. And then do it again, Control C, Control V. And I can put this right here. So we can see, click your 3, paste that twice. That 4 copies of 3 make 12. So that is how we show 4 times 3 equals 12. Down here, this is in our illustrative curriculum, also on Open Up Resources. This is called Matching Equations and Tape Diagrams. So for each of these, we're going to identify whether it is a sum or whether we are looking at multiplication. 4 plus x equals 12. So I can see from left to right, I have a 4 and an x, and it all adds up to 12. So I'm going to take this one, highlight it, and drag it here. And then I'm going to hit my right button and then enter so I can write on the next line. 12 divided by 4 equals x. So here I have 12, and it's broken into 4 equal pieces, and each equal piece equals x. So this goes here. Then we have 4 times x equals 12. Well, I know that multiplication and division are inverses. So let me check the one that we just put the division on. And we have 1, 2, 3, 4 copies of x, and left to right it's equal to 12. So this one would go here. 12 equals 4 plus x. We can see that these are the same, except they're switched on the sides of the equal sign. Let's see, the next one, 12 minus x leaves us with 4. So this one again goes here. Are you noticing the pattern that the addition and subtraction ones are together and the multiplication and division ones are together? Because here we have 12, our total, equals 4 times x. So I'm going to predict that this one will make sense here. 12 minus 4 equals x. 12 minus 4 leaves me with x. And we know that this is equivalent to that one. This last one's a little tricky because it has addition, but I don't have 4 x's here. So this is repeated addition, which can be represented as multiplication. So x plus x plus x plus x makes 12. Once you finish this, you're going to go down to practice 1. It says, here is a list of expressions. Choose an equivalent expression from the list below the table. That's down here. Then copy and paste your expression to the matching equivalent column. So I'm going to look at this. A plus 3. Which of these down here is equivalent to a plus 3? Well, 1/3 plus a is not going to be equal to that. And a plus 3 can't equal a. But a plus 3 could equal 3a. So I'm going to hit Control C to copy and scroll up and Control V to paste. So that is your strategy. And just as an FYI, we call this the commutative property because the A commuted, like we do on a train, to the other side. It moved. Addition and multiplication both have the commutative property. It means we can switch the order. Well, excellent work. I'll see you soon.